Hi everybody, in this video we're going to go through all of the constructions learned in geometry so far. So the constructions that we're going to do in this video are the perpendicular bisector construction, perpendicular line through a point, parallel line through a point, copying an angle, angle bisector, constructing different kinds of triangles, equilateral, isosceles, and scalene, and triangle centers, the circumcenter, orthocenter, incenter, and centroid. Okay, we're going to construct the perpendicular bisector of this line segment. Put your compass on one endpoint of the line segment and open up more than halfway down, about 3/4 of the way, but the exact distance doesn't matter. And what we're going to do is we're going to swing an arc above and below, and without changing the distance on our compass, we're going to go over to the other endpoint and we're going to swing the same arc above and below. We need those two intersection points. Ooh, let me draw that a little bit better with my straight edge. So right through the two intersection points, we're going to use our straight edge and we're going to draw our bisector. And notice what we have here is the perpendicular bisector of line segment GH. Not only is it perpendicular to it, forming 90-degree angles with it, but it also cuts it in half. And that means this point that it passes through is the midpoint of the line segment, because it's the point where the line segment is cut in half. Now we're going to construct a perpendicular line through a point. It doesn't matter if your point is off the line, like the point here, or if the point is on the line, like the point here. It's the same construction. We're making a perpendicular line to the one that's given through the given point. What we're going to do, since we need our perpendicular line to pass specifically through point N, is we're going to take our compass and we're going to put it on point N. And then we're going to just swing an arc. Let me open it a little bit. And it doesn't matter the distance you use for this arc. All that matters is that when you swing this arc, it does need to intersect the line in two spots. Oops. So notice here, this arc intersects the line in two spots. Spot here and the spot here. That's where I'm going to put my compass. Going to put it on one of those spots. And make an arc any distance. And then on the other intersection point, and make the same arc any distance. Where the two arcs intersect is where I'm going to use my straight edge, and I'm going to draw my perpendicular line, and it should come really close to passing right through point N. Notice how it's perpendicular to the given line, meaning that it forms a 90-degree angle where it intersects it. I'm going to just run through these steps one more time with the point that's on the line. It's the same process. Take your compass and put it on the point that you want your perpendicular line to pass through. Swing an arc. And once again, the only thing that matters is that your arc hits the line in two spots. We have here and here. Going to take our compass, and put it on one of those points first. Doesn't matter how much we open. using the same distance, going to go over to the other intersection point and make the same arc. And my first one wasn't long enough, so I'm going to go back over to the first intersection point and just continue my arc a little bit. Right through the intersection, I'm going to make my perpendicular line, and it should come really, really close to passing right through point R. We're going to make a parallel line to the given line that passes through the given point. So to do that, we need to start off by making a transversal, which is any line that goes right through point N. I recommend making it slanted because if you make it a straight vertical line, it's going to make your construction a lot more difficult for no reason. Now, the way that we're going to be creating this parallel line is by making congruent corresponding angles. And if corresponding angles are congruent, lines are parallel. So I'm going to put my compass right here on the vertex of the angle that I want to copy. And I'm just going to make an arc that intersects the angle at 2 spots. And whatever distance I used, once again, the distance doesn't matter, but whichever one I used, I'm going to come over here to point N and I'm going to make the same arc. Now is when I actually have to measure this angle. So I'm going to measure between the 2 endpoints of the arc on the angle. I'm going to put my compass on one point. And I'm going to match up to the other. And I'm going to swing an arc to show that I measured. Now I'm going to come up here where my first arc hit the line. And I'm going to swing an arc using the measurement that we measured. And through that intersection point, oops, my straight edge on the computer is horrible. I'm going to try that once again. I think that got worse instead of better. There we go. That's the best I could do. I kind of missed when I was doing it on the computer. One more time. There we go, finally. And notice how the line we created is parallel to the original. And the reason why it's parallel to the original is because we created these congruent corresponding angles. And when corresponding angles are congruent, the lines are parallel. Now we're going to copy an angle, which is the construction that we just did. So we're going to take the angle that you see here and we're going to move it exactly the way it is with the measurement and all to another spot on our paper. So we're going to set this up. I'm going to make another point and I'm going to make a ray because my angle consists of 2 rays. And what I'm going to do is I'm going to put my compass, on point P. I'm going to open up. The distance doesn't matter. And I'm going to swing an arc. And then I'm going to go over here to the point that we dotted. And I'm going to make the same arc. Now, I actually have to measure the angle to get the actual measurement. I'm going to put my compass on one of those points. And I'm going to open up to the other. And swing an arc to show that I measured. And then what I'm going to do is I'm going to come over here where my arc hit the ray. And I'm going to make an arc and keep going until it intersects with the first arc. Now, right through that intersection point, starting at the vertex, oh no, I'm going to draw the other ray of my angle. Remember, rays don't have length, so don't worry about if you draw them longer or shorter. They have arrows on the end, they don't have length. What we're concerned about when we're copying an angle is the angle measurement, which we got from measuring from point to point and copying that measurement over here. So we have two congruent angles here, exactly the same measurement. Okay, here we're going to be bisecting an angle. So what we're going to do is we're going to put our compass on the vertex of the angle that we're bisecting. And we're going to swing an arc. It does not matter the distance that you use for this arc. Then I'm going to put my compass on each of these two places where the arc intersects the angle. And I'm going to open up just a little wider. The exact measurement doesn't matter. And I'm going to make an arc. Then I'm going to come over to the other endpoint. And I'm going to make the same arc. With my straight edge, starting at the vertex, through where the arcs intersect, I'm going to draw my angle bisector. And notice how it cuts the angle exactly in half into two congruent pieces. Okay, we're going to construct an equilateral triangle now. For an equilateral triangle, I just need a line segment to start with. Since it's an equilateral triangle, all of the sides are going to have the same length as this line segment that I created over here. They're all going to have the same side measurement as this line segment. So first what I'm going to do is I'm going to copy the measurement of the line segment. And I'm going to mark a point where I'm going to start my triangle. And I'm just going to take this measurement that we just measured. I'm going to go over to that new starting point that I just dotted. And I'm going to swing the arc. And from that point, oops, there we go. From that point to the arc, I just use my straight edge to draw my line segment. And that's going to be one side of the triangle. Without changing the distance on my compass, because it's holding the length of this line segment right now, I'm still on the point that we marked. And I'm just going to make an arc. Then I'm going to go over to the other endpoints. And I'm going to swing the same arc. I'm going to connect from here to the intersection point. And I'm going to connect once again from here up to the intersection point. And here we have an equilateral triangle where all three sides are equal. Now we're going to make an isosceles triangle. So I'm going to start with two line segments of different lengths. Just like we did before, I'm going to mark a point, and that's going to be my starting point for my triangle. First, I'm going to measure the longer side because I'm going to use that as the base of my triangle, the bottom. I'm going to take that measurement and I'm going to bring it over to my new starting point, and I'm going to make an arc. Using my straight edge, I'm going to connect together, and that's going to be one side of my triangle. Now, I'm going to get the measurement of my other two sides, and I'm going to get that by measuring the other line segment that is going to represent the other two sides of my triangle. I'm going to take my compass with the measurement without changing the measurement, and I'm going to put it on one of the endpoints. And I'm going to swing an arc. And then I'm going to go over to the other endpoint, and I'm going to swing the same arc. Then I'm going to connect from point to intersection point and from point to intersection point. And there I have my isosceles triangle. It has two sides that are equal and one side that is different than the other two. Finally, we're going to do scalene triangle, and it is pretty much the same thing. So I'm going to start with 3 different length line segments. And just like before, I'm going to mark my starting point. First, I'm going to copy the longest line segment because I want that to be the base of my triangle. I'm going to take the measurement and I'm going to bring it over here to my starting point. I'm going to swing an arc. Then using my straight edge, I'm going to connect from the point to the arc, and that's going to be one side of my triangle. Now I'm going to get another side of my triangle. And I'm going to do that by measuring the second line segment that I have here. Without changing the measurement on my compass, I'm going to go over to one of the endpoints, and I'm going to make an arc. Then I'm going to go over to the other endpoint. Oh, nope. So I went over to this endpoint and I made an arc, but I forgot I have another side I have to measure. I was trying to make an isosceles triangle again. So this one's going to be even smaller, I see. So I'm going to go over and open up so I can get this measure. Then I'm going to take my compass and go over to the other endpoint that I didn't yet go over to. and I'm going to make an arc. And I didn't extend this one long enough, so I'm going to pause and just extend it further. And here, let me just connect together and connect together. And here I have my scalene triangle with 3 different sides of different lengths using the 3 different line segments. Okay, now we're going to make the circumcenter of a triangle. I'm going to use this acute triangle. Now the circumcenter is where the perpendicular bisectors meet of a triangle. So I'm going to do this side first. So I'm going to put my compass on here and here to make the perpendicular bisector on the endpoints of the side. Remember, open up about 3/4 of the way down. The exact measurement doesn't matter. Then I'm going to go over to the other endpoint. And I'm going to do the exact same thing. And there's my perpendicular bisector. Notice how it's cutting the side of this triangle in half. Now I'm going to do the perpendicular bisector for another side of the triangle. I'll just do this side over here. One endpoint. Other endpoint. And here we have our other perpendicular bisector. You could do a third one for the third side, but we're not going to in this video because we can see where the perpendicular bisectors meet. So the circumcenter is where the perpendicular bisectors meet. Now we're going to construct the centroid of the triangle. Notice that I have the 2 perpendicular bisectors here. I'm just going to get rid of the intersection point because we're not going to be talking about the circumcenter anymore. Centroid is made up of medians of a triangle, and medians connect midpoint to opposite vertex. So since we have perpendicular bisectors here, we have the midpoints of the sides that we bisected. So all we need to do is take our straight edge and connect the midpoint to the opposite vertex. And same thing over here, midpoint to opposite vertex. And now we can see where the centroid is. The centroid is the point where the medians meet. Remember, medians connect midpoint of a side to the opposite vertex. Okay, now we are going to talk about the incenter of a triangle. The incenter is where the angle bisectors meet. So we're going to be doing the angle bisector construction. So I'm going to go over to one of the angles, to the vertex, and I'm going to make an arc. And now we're going to put our compass on the 2 intersection points. Doesn't matter how far you open. I'm going to open a little bit more. And I'm going to make an arc. And then we just need to go over to the other intersection point and make the same arc. from the vertex through the intersection point, we're going to make our bisector. Now we're going to do it for another angle in the triangle. And the point where the angle bisectors meet is called the incenter of the triangle. So here we have found the incenter of the triangle. The last one that we have is the orthocenter of a triangle, and that is where the altitudes of a triangle meet. An altitude is a perpendicular line through the opposite vertex. Since it's a perpendicular line that has to pass through a specific point, it's just going to be the perpendicular line through a point construction. I'm going to start with making the altitude to the bottom, the base of the triangle. It would have to pass through the opposite vertex, which is this point right here. From the side, this vertex is opposite. So I'm going to start off by putting my compass on the point that I want my perpendicular line to pass through. And then I'm going to swing an arc. Oops, too big. Let me go a little bit smaller. There we go. And now it's all good because our arc intersected the side of the triangle in two different spots. Now that we have those two intersection points, all we have to do is take our compass and put it on one of those points and make an arc, and then go on to the other point and make the same arc. And we're going to use our straight edge, and we're going to connect, we're going to connect from the intersection point to the opposite vertex. And now we just have to do the same construction for one other side of the triangle. I'm going to do this side over here. If I'm doing this side of the triangle, the opposite vertex from this side would be this vertex. So I'm going to start off by putting my compass on the vertex that I wanted to pass through. And I'm going to make an arc that hits the side of the triangle in two spots. It hits the side here, and it hits the side here. So now I'm going to go over to each of those intersection points I'll go to the top one first. And then I'm going to go to the bottom one. And using my straight edge, I'm going to connect from the intersection point to that vertex I wanted it to pass through. And here I have another altitude of the triangle. And this point right here, where the altitudes of a triangle intersect, is called the orthocenter of the triangle. And once again, it's where the altitudes meet.